Hello and what's up, everyone? Welcome to day 4 of our final review. We're almost there. We got this PowerPoint and one more, and we're almost done. Today we are talking about triangles. We're talking about theorems. We're going to do some proofs, some little bit with angles, sides, things like that. So let's jump into it. First problem here, we see a triangle and it says determine the value of x. And we notice that x is in a position where an angle value would be. So measurement of an angle. And we know in a triangle we have three angles, which we have all three labeled 4x, 2x, and 24. And what that means is we could add these together. We could do 24 plus 4x plus 2x. And we know that when we add up our angles of a triangle, they will always equal the magical number of 180. So then what we could do is combine our like terms, and we could get, I'm going to move it to the front, 6x plus 24 equals 180. And then all we have to do is solve for x. So we subtract 24 on both sides, and we're left with 6x equals 156. And now all we have to do is divide by 6 on both sides. I'll go to my trusty dusty calculator. 156 divided by 6 is going to give me 26. So we get x equals 26. And there is our answer. Just like that. Next up, we're going to use the same idea. Now this one says determine the value of x and y. We have two variables here. And if we just added these angles up, we wouldn't be able to figure out both. But notice we're given more information. Both these lines have dashes on them, which means they're congruent. That tells us that this is an isosceles triangle. And when we have an isosceles triangle, that means that our two sides are congruent, but the opposite base angles are going to be congruent. So that means 52 and y are congruent to one another, which means that y is equal to 52. Easy. And now that we have that, now we could just add the rest of this up. So we're going to say 14x plus 6 plus 52 plus 52, and we know that has to equal 180, just like last time. Now we get 14x, and we have to add our constants together. 52 plus 52 is 104, plus 6 will give me 110, equals 180. And now, finally, we subtract 110 on both sides, and we get 14x equals 70. And now we have to, I'm going to rewrite this over here. Actually, we're going to divide both sides by 14. And what we're going to get from that is x equals 5. There we go. We got our value of y here. We got our value of x right there. Nice and beautiful. Now, be careful. If I ask you for the value of the angle, we would have to plug that x back in, right? And then we could find the angle of ABC, the angle ABC. Next up, now we're dealing with angles, but this isn't a triangle, and they're on the outside of this figure. Now, the first one says, consider the polygon shown, use the given information to answer the questions. First question says, determine the value of x. Well, if we look at x, we see it right here, and right next to it is a right angle. Well, what we notice is that right angle and the angle that has the value of x, they create a straight line, which we know a straight line is 180. And that means that if we have 180 minus 90, that also equals 90. So the value of x equals 90 degrees. So x is also a right angle. So we got one down. Now we need to figure out what y is, right? Well, we have to use this idea here. It's the sum of the angle measures, right? So we have our interior angles, but hey, our exterior angles will always add up to 360. No matter how many sides the shape has, they will always add up to 360. So let's do that. We start out, we know that this is 90, so we'll put 90 plus, then we hit y right here, plus 75 plus 67 plus, this doesn't have a value. But there is one thing that we notice right next to it. It has an angle marker. Right next to the one that has y has an angle marker too, which means that if these are congruent, their outside angles are going to be congruent. So this also has to equal y equals 360. Now what we have to do is add our y's together. We get 2y. We have to say 90 plus 75 plus 67. I don't want to think that out, so we're going to do it in a calculator. Oops, typing in wrong. 90 plus 75 plus 67 gives me 232. Oh, I put an equal sign after a 2y. That's not supposed to be there. It's supposed to be a plus sign. 232 equals 360. And now we just solve this equation. Subtract 232 on both sides. And we're left with 2y equals 360 minus 232 would give me 130, 128. Divide by 2 on both sides, and we get y is equal to 64. And there's your answer. I'm just going to be right up here to make everything look nice. There we go. Next up, it says the portable basketball hoop shown is made so that BA is equal to AS is equal to AK. Let's mark all of that off. So BA is here, is equal to AS, which is here, which is equal to AK, which is here. That means we have two isosceles triangles here. ASK is an isosceles triangle, and ABK is an isosceles, which means that their base angles will also be congruent, which I'm going to mark off now. I'm going to use different angle symbols, though, because these angles are obviously not the same size. You could just look at them and tell that. Now it says the measure of angle BSK is 76 degrees. Calculate AKB. So ASK is 76, which means that AKS is 76, right? And we have a exterior angle here for triangle ASK, which means that if we add 76 plus 76, 76 plus 76, which would give me 152, that is the measure of this angle here, because that's our exterior angle theorem, right? Our exterior angle theorem says if we take our two remote interior angles, which we did this on one of our previous PowerPoints, the two remote interior angles are the angles that are not touching it. We add it up and then boom. Now, we could figure out the rest of this. Why? Because these two angles have to equal the same thing. So what we could technically say is 152 plus x equals 180, which is the whole entire triangle here. So then what we could do, finally, is say that 2x plus 152 equals 180. And then we'll go, we'll subtract 152 on both sides. And we get 2x equals 28. Divide by 2 on both sides. And we get x is equal to 14. And there's your answer. Boom. Nice and easy. Next up. Now, next up we have our special right triangle of a 30, 60, 90 triangle. And we're given the rule down below. And we just want to find the other two parts. So in both of these triangles, we're given the side that's across from my 30-degree angle, which is my short leg. Same thing here is my short leg. And that's good because that is our reference leg. That is our short leg, right? And then B is going to be my long leg. And then C is my hypotenuse, which is the side that's across from my right angle. In a picture down below, x times square root of 3 is my long leg, and 2x is my hypotenuse. So finding the hypotenuse is the easiest thing. All we do is multiply it by 2. So 3 times 2 will give me 6 here. And my other one, 5 times 2 will give me 10. And then down below, all we have to do is multiply it by radical 3. So down below, I'm going to have 3 radical 3 in my first one. And then we're going to get 5 radical 3 in my second one. And there we go. We have our answer. Very, very simple. Just use the rules of our 30, 60, 90 triangle. Next up, it says circle O has a diameter AB, a chord AC. State the conjecture about the relationship between angle CAB and BC, the arc, and use it to calculate the measure of angle CAB if arc BC is 62. So I'm going to label that BC 62 degrees. And it says CAB here is that's the angle we're looking for, right? So what we know down here is this is an inscribed angle, and our inscribed angle rule is that our angle is half of the arc. So if we could write this rule for our current situation, we could write angle BAC equals 1/2 of arc BC, right? This angle here is half of this value of the arc that it intercepts. Because notice, if we start at A, follow both lines, and it brings us to the points that stop that arc. So now what we could technically say is measure of angle BAC is equal to 1/2 times 62. I just substituted in the value, which means that the measure of angle BAC is really equal to 31 degrees. There we go. Nice and simple. Next up, we have our different rule. It says use the diagram to determine the measure of each. So we want to determine the measure of arc FI. That's what we're starting out with here. If we know that K is equal to 20 and GJ is equal to 80. So we have to figure out what situation we have going on down here because there's different rules. So do we have situation 1, 2, or 3? Well, if we look, both lines in situation 1 cut through the circle twice, which means that they are secant lines. And that's what we have here. We have two secant lines that intersect at point K. So we're going to use situation 1. So we're just going to rewrite our rule for this situation. It says the measure of angle 1, which in this situation is angle K, is equal to X minus Y. X is this outside arc, which is FI in this situation. You're going to say FI minus Y, which is my inside arc, GJ, over 2. So we're basically just taking the average of these two things. So now let's plug in the values that we know, right? So measure of angle K we know is 20 degrees, which is equal to, we don't know FI. That's what we're looking for. So we're going to put FI. We're just going to leave it like that, right? That's what we want to know. Minus 80 over 2. Well, the first thing we have to do here is get rid of this 2. We can't have a denominator and try to get to FI. So we're going to multiply both sides by 2. That's going to give me 40 equals arc FI minus 80. Now what do we have to do? We have to add 80 to both sides. When we do that, we finally get 120 degrees is equal to arc FI. And there we go. We got our answer using rule number 1. So we just identified each part that represented each other, wrote the equation with our parts in it, and then plugged in our values and solved. Next up, we have another rule here. We have another situation. So now we have 2 more secants, but we have angles on the inside of this, and they give us different lines, right? Now, these are not central angles. So that messes up this whole situation where we say, hey, the arc is equal to this angle. That only happens when if T was the center of the circle. As we could tell here, T is not the center of the circle. So we have to use our formula down here. And it says the measure of x, which x is this inside angle, which for our case, it's RTU. That's the angle we're looking for right here, RTU, is equal to 1/2 of the two arcs added together. So let's do that. But let's rewrite it for our case. The measure of angle RTU is equal to 1/2 of arc RU. Oops, that's a B. My bad. RU plus arc SV. Right? And now we just plug everything in. Do we know the measure of angle RTU? No, that's what we're looking for. We know what 1/2 is. Do we know RU? Yep, it's 110 plus 78. When we say measure of angle RTU is equal to 1/2 of 188. And finally, that means the measure of angle RTU is 94 degrees. And there is our answer. The hardest part here is just setting up our equation. Once you have that set up, then we plug everything in, and then we just solve. Simple algebra skills from there on out. Next up, we got a proof. Oh man, how did we miss these, didn't we? So this proof says complete the two-column proof for the following theorem. We're told that PQS and RQS are right angles. So let's mark that off in our picture. PQS is a right angle and RQS is a right angle. Those are two things we're told. We want to prove that PQS is congruent to RQS. This should be easy. So we start off with our given PQS and RQS are right angles. So our first one says that the measure of PQS is a right angle. Well, your question should be, how do I know this? Well, I know this because they told me it's a right angle. So that is our definition of right angles, just like the statement below it, which means that we must be stating that our other angle, RQS, is also 90 degrees. And now it says the substitution property, which it just means that these two things have to be equal. The measure of angle PQS is equal to the measure of angle RQS. And why is that true? Well, that's true because they both equal 90. This also might be known as our transitive property. So they use substitution property. I personally would have used transitive property because when two things are equal to the same thing, they must be equal. And finally, all we see is them get rid of these m's in front and they change our equal sign to a congruent sign. That means we have our definition of congruence. Definition of congruence. And there we go. We completed our fill-in proof. Awesome work. And next up, we have one more proof. We have to just write our reasoning down for it all. Here it says complete the flowchart proof by writing the reasoning for each statement in the boxes provided. And we're given that AB is congruent to DE, which is the entire segments that we have in our picture to the right over here. So the top segment is congruent to the bottom segment. And we also know that CB is congruent to FD, which we could see in that picture by the markings. So our first two statements are going to be our given statements. Given and given. Then they both have a line and they both do the same thing. They change their congruent sign to equal sign. That is our definition of congruence. I'm going to abbreviate to def of, and I'm going to put the congruent symbol. So definition of congruence. And next up, we see that number 3 splits into 5 and 6. And this says that AB is equal to AC plus CB, which if we notice, AB is equal just to these two smaller segments. This is our segment addition postulate. Segment addition postulate. And that goes for both of these. Segment That should be segment, not segment. Addition. Ah, shit. Whoops. Now, obviously it's hard to write in these tiny boxes. It'll probably be harder for you guys too. So what you guys could do is if you just want to put a 1, write your answer, a 2, write your answer, so on and so forth. That would probably be easier. So the reason for number 7. Now we're saying, hey, well, we said that A, B, and B, D, E are equal. So these whole things must be equal. This is our transitive property. That's our transitive property. And then what do we do next? Well, we subtract CB and FE, or CB and DF. So that's our subtraction property. And then finally, we say that since they're equal, that means they're congruent. That once again is our definition of congruence. We're just going in the other way this time. Here we went from congruent to equal. Here we went from equal to congruent. And there we go. We completed our proof. And that is the end of this review. So once again, if you have any questions, comments, or concerns, please, please, please let me know. Let your teacher know. Or drop a comment down below and ask for help. Thank you for watching, and peace out, everybody.